Hello there. A warm welcome to all of you present today. In this episode of the FlytNow webinar series, we'll go in depth on BVLOS operations and the key components that go into making these drone operations viable. While there are many important factors to consider when operating beyond the line of sight, such as the aircraft, the dock to refuel the drone's batteries, the operating environment, the training program for remote pilots and observers, however, the most crucial considerations would be flight safety and the ability to mitigate risks on air, ground, people, and property. Therefore, majority of the BVLOS flights happening today require the presence of a visual observer who constantly monitors the skies for any potential obstacles that the drone may encounter. And to do so, if they do so, they need to promptly inform the remote pilot in command to abort the drone's current mission. Therefore, it goes without saying how dangerous any communication lapse could be. Moreover, as the drone operations expand, just imagine the amount of resources and personnel that would be required to keep a constant eye on the sky. It is therefore critical to employ newer technologies and innovations to conduct safe and efficient BVLOS operations that do not rely on the human eye. So how do we solve it? To do so, I'd like to introduce our guest speaker today. He is a global sales leader dedicated to building a safer airspace through perception technology. As the Director of Global Sales and Customer Success for Iris Automation, his goal is simple: to ensure that no two aircrafts ever collide in midair. He has a long history of working in technology and has a strong background in SaaS, edge computing, IoT, and regulatory compliance. Over the course of his career, which includes time at Oracle and Verisk Analytics, he has had the pleasure of working with a number of Fortune 500 companies, helping them to contract custom SaaS integrations and advising them on how to navigate complex regulatory environments. He holds an undergraduate degree from Connecticut College, where he graduated with honors and did additional courses of study at the Tufts University and New York University. In his free time, he happily annoys his wife and young son with his guitar playing and is deeply involved in building up the Boston water polo community as both a player and a referee. So please welcome on stage Daniel Oshia. Welcome, Dan.
Hey, everybody. Well, huge thanks to you, Basali, and to Achal for having me here today. And of course, a massive thank you to the entire FlightBase team for hosting this webinar series. And thank you to everybody that's on the presentation watching me today. I'm really excited to talk about the partnership that we're launching with FlightBase. the integration into the FlytNow application, and just how we can help customers navigate BVLOS requirements and build a safer airspace. So thank you all for your attention, your questions in advance, and for putting up with me over the course of the rest of this presentation. Next slide, please.
Before Dan, I pass on the dice to you, I would also like to introduce my colleague and FlightBase's Director of Business Development, Achal, to come share with us how FlytNow, FlightBase's flagship product on automated drone-in-a-box operations, is ensuring safety in operations. And again, before I pass it on to you, I'd just like to share a few housekeeping rules for the audience. So audience, you could feel free to ask any questions by just typing them in the Q&A section. And the webinar is being recorded and we will publish it online soon for your further references. So Dan, the stage is all yours now.
All right, thanks. Sorry for jumping the gun there a little bit. All right, let's hop to the next slide, please.
Yes.
All right, so over the course of this presentation, everybody, I'm going to basically give a little bit of a brief background about who Iris Automation is for those of you that might not be familiar with us and our work, what our goals are as a company, and just a really high-level overview of some of the different products that we provide before going into a deeper dive about the system that we've integrated into FlytNow, a system that we call Casia G. And then we'll do kind of a higher level overview of kind of where Casia G fits within BVLOS operations, how it builds a safer airspace, some of the requirements that are placed on operators, and then how that's translated and how the work that we've done as a company has translated into some regulatory successes that we can hopefully pass on to the folks on this call as well that might be interested in pursuing that route. So a little bit about Iris Automation. So we were founded originally in 2015. We were actually founded at first in Canada, but we moved operations down to the United States into first the San Francisco Bay Area and eventually settling in Reno, Nevada. As a company, we have one goal, and that is to ensure that no two aircraft ever collide in midair again. And we do that through really two different types of services offerings. One is through our detect and avoid hardware, branded Casia. We manufacture a number of different systems that go on board and off board, different types of aircraft, and also through professional regulatory consulting, professional services, and regulatory consulting to help customers navigate the complex environments that they might be dealing with. Next slide, please. So we started in the onboard detection arena, and when we started manufacturing the Casia system, we started with a single camera system, expanded into a second multiple camera system, Casia 1 and Casia X respectively. And these systems are really useful for what they do. They serve a really important purpose. And the idea is, next slide please, that with an onboard detect and avoid system, you kind of create a bubble of sterilized airspace around your aircraft. And for certain types of operations, that can be enormously valuable. When you're flying, potentially dozens or hundreds of miles doing long linear asset inspection, think pipelines, power lines, etc., long duration search and rescue events, or anything that involves, essentially flying a super long distance, then being able to take a protected bubble of airspace around your aircraft with you as it goes flying around is really critically important. And I think we can all see, how that's valuable. But there are some downsides to this model, right? First and foremost, there are only a small number of drones that are actually manufactured to incorporate non-cooperative detect and avoid systems. There are some that have built-in ADS-B detection or FLARM, but the number that have vision systems like ours, or radars, or acoustic systems designed into the drone are really slim. There just aren't that many out there, and most commercial operators are using smaller drones that cannot support the payload. Regardless of whatever type of system we're talking about, they all have mass, right? They're all going to weigh something, and they're all going to extract power from the battery in order to do their job. And some are way less than others, some take more power than others, but they all do this, and not every drone is going to be able to support them. Integration with these systems across the multitude of different flight control systems that are out there are hard too. So, there are, different programming languages like Mavlink to help with this, but there are also, for every customer that might be using a Mavlink-based flight control system or autopilot, there's probably about one or two more that are using proprietary autopilot systems. And so being able to integrate in with all those is really difficult at scale. So we decided instead, to help these customers that want to conduct BVLOS missions but can't support onboard systems. Well, next slide, please. Why don't we take it off the aircraft and put it on the ground? And this is where the vision for Casia G came in. So, when we're talking about repeated operations in an area with smaller footprints, so things like power substations, ports, and where you might be using a system like a drone in a box system, austere locations with small drones that really just would thrive without having humans in that direct environment with the actual aircraft system. Well, Casia G becomes a really good solution set for that. Next slide, please. All right, so this is the Casia G system. It's pretty small, right? It weighs about 4 kilograms, 10 pounds if you prefer to use Freedom units. And the system is really easily set up. We can put it on multiple different types of mounts. We can put it on tripods. We could permanently affix it to buildings. The power draw is quite low, 65 watts overall. So we can attach that to a battery, solar panels, to be able to put this out in austere locations. Now, how does this system work? How does it do what it's How does it do what it does? And basically, how does that translate to a benefit of your operations? So Casia is a electro-optical system that also uses an ADS-B antenna. So what do I mean by electro-optical? So we have 6 machine vision cameras that feed a live video stream into a graphical processing unit that houses our deep learning algorithms. And what we do is we are looking for moving objects. And when we pick out a moving object, we try to positively identify what that is. So basically we say, okay, hey, that object over there, that's a helicopter, or that's a plane, that's a bird, that's a drone. So we try to build out these classifications, and we have a 97% overall detection rate. So 97% of intruders that enter into the surveillance volume, we're going to be able to detect them and identify what they are, which is really, really great, quite frankly. It's hard to do this, and we'll show exactly how hard it is to kind of pick out these different types of targets in a later slide. But we can combine that with ADS-B detection as well to provide cooperative detection. Now, I've thrown out a couple terms here that may not be familiar to everybody on the call, and that is non-cooperative detections versus cooperative detections. Cooperative detections really simply are just aircraft that are transmitting their location or are otherwise in communication with air traffic control. They're basically making themselves known to other users in the airspace really visibly. Non-cooperative aircraft don't have that capability. Either they don't need to because they're flying in airspace that permits them to fly legally without transponders on board. Maybe there's human error and somebody forgot to turn on their transponder. But these non-cooperative aircraft are out there, and depending on where you're flying, there could potentially be a lot of them. This is a large problem here in the United States where I'm located, up with our neighbors in the north in Canada, and it's a particularly large issue, I believe, in New Zealand as well. So non-cooperative aircraft are out there, and trying to find them and avert collisions with them is really, really difficult. The Casia G system helps with that, and with the ADS-B antenna will catch cooperative traffic as well. So each system sees out to an average range of 2 kilometers and 2.8 kilometers max detection range. Next slide, please. So that's a pretty hardy detection range, just over a mile if you're in the United States, and that affords a pretty decent operational area. So if you're working on something like a substation or a building with a relatively restricted footprint where you have operations, say, for security or perimeter patrols, or maybe just asset inspections on site. Well, a system like that, a single node co-located with your drone in a box solution, could end up being enough to cover your entire operational area. But we didn't limit ourselves to just the one deployment. Next slide, please. We can mesh network these things together. And this is where this is part of what a tool like FlytNow is able to do, which is you can provide an overlay and show surveillance over a large operational area and be able to catch non-cooperative and cooperative traffic that could pose a collision risk. So when we start networking these things together, now instead of being limited to a substation or a single property, we can start looking at things like rail yards, ports, or even entire cities. And we're working with a number of different customers to do these expanded operations that involve multiple nodes as we speak. Next slide, please. So yeah, so what are the things that we detect? I already started alluding to this, right? So we've designed this for non-cooperative detection, and we particularly designed it for small aircraft because those are the most likely ones that you're going to encounter during your everyday drone operations. It's really, if you're encountering a 747 below 400 feet, you probably got a problem, right? But it's really not uncommon to have helicopters pop up in relatively short order, or small general aviation aircraft like Cessna 172s or seaplanes. So we've done an enormous amount of testing and data gathering to basically test our system against a number of different aircraft types. And this is actually just from some recent testing and data gathering that we did outside of our VP of Operations house in San Francisco. Kind of hard to tell on this slide, at least on my screen, but you can actually see where the system is set up. You can see the Golden Gate Bridge in the background. So we get lots of general aviation traffic, and we even actually captured a number of FA-18 Hornets. So the US Navy's demonstration team, the Blue Angels, flew over San Francisco during Fleet Week, and we were able to get a number of detections with fast-moving fighter jets, which was very, very cool to do. But there were other airspace users during that time as well, including parachutists, which is what we see down in the lower right-hand corner. So we were able to get a number of really great detections on a number of different aircraft types. Next slide, please. So, and it just doesn't go, and it's not just, testing at our VP of Ops house VP of Products house in San Francisco. We have our own flight team and our own flight facilities in Reno, Nevada, and we've done over 16,000 real world encounters to date. So various versions so all of the Casia systems use fundamentally the same software architecture. They're using the same detection algorithms. And so when we say 16,000 encounters, some of those are with the Casia 1 and Casia X onboard systems. Some of those are with our forthcoming Casia for General Aviation system, and of course some of those are with Casia G. But all of this has basically resulted in over 600 terabytes of flight data recorded. And then next slide, please. We've also bolstered our performance by using really robust simulators. So we built out 2 simulators to help test both environmental our performance in different environments and our performance in different actual intruder situations. So we built a photorealistic simulator that can put in where we can simulate haze, smoke, low light conditions, basically conditions where it would be a little bit too dangerous to fly or have a real person to fly, or that might be difficult to duplicate on demand given how weather works, but also to put in terrain features and geographical features that just don't look like Reno, Nevada, because not everywhere in the world does, right? But also we built out a really robust encounter simulator where we can do all the things that would make the FAA absolutely lose their mind if we did them in real life, like have a helicopter pop up with little to no notice in front of the drone, or have multiple aircraft converging together within a couple hundred feet of each other on the drone as well. So we've done over 250,000 encounters in our 250,000 environmental simulations and over 1 million encounter simulations to test our performance in different types of intruder situations and on different types of aircraft types. Next slide, please. So we've done a lot of work. We've created a really robust packet of data. So how does this actually help BVLOS operations, and why do we want to fly BVLOS in the first place? Well, we've kind of alluded to this in a couple different ways over the course of the presentation so far, right? Like, so, you could, flying hundreds of miles to do pipeline inspection is just not scalable if you're utilizing visual observers, right? Having a visual observer placed every 2 to 3 miles along the pipeline, well, how many visual observers do you need? And at what point would it just be cheaper to get a helicopter, right? Similar thing with power line inspections, railway inspections, drone as first responder programs, which are especially popular here in the United States and are starting to spread elsewhere in the world where police forces proactively deploy drones, not just from the back of the police cruiser, but from on top of a police station to respond to emergencies before first responders even get there. So they have a really important source of reconnaissance on site early. Those are really starting to pick up, and having visual observers out on every rooftop across the city just is not scalable, particularly when those visual observers are usually police officers and they have more important jobs to be doing at that point in time. So we can really start to see the benefit of BVLOS, and we can start to see some of the shortcomings of the current model of visual observers. Next slide, please. But that doesn't preclude our responsibility as drone pilots. Now, this is a copy of US federal regulations, but every country has their own version of this. The FAA says explicitly that every pilot in the national airspace, and it doesn't matter if you're flying a drone, a helicopter, or a fixed-wing aircraft, must see and avoid other aircraft. That is a federal legal requirement of every pilot. But doing so can be really difficult. Next slide, please. So I'll give an example of this. So this is a picture from our onboard system, right? So this is what Casia 1 would see. Now, we do have an intruder in the shot. Now, ignore for a second that we've got a little kind of neon green bounding box around the intruder. Imagine you're looking at like a 4-inch screen on a controller. How difficult would it be to detect what that intruder is, if number one, if that intruder is even there, what it is, and recognize whether or not you need to get out of the way. Next slide, please. It's really hard, right? Especially if you, the pilot on the ground, are obstructed by trees or buildings, and you can't see far enough out to see that intruder. It can be really, really difficult. And so this is where a detect and avoid system can come in to help. Next slide, please. And these collisions, unfortunately, do happen. I was actually listening into a presentation given by a couple members of the FAA just last week. They gave a couple stats that were pretty eye-opening to me. There have been 7 documented cases of drones colliding with helicopters in the United States, and that's just helicopters. And the other stat, and there was really not anything that tied in these different types of collisions together. And what I mean by that is, some of them were recreational, some of them were commercial. They all happened in different places, different environments. But the one thing that kept happening was that, or the one thread that ties them all together, is that in each instance, the pilot was looking down at a screen. I'm going to let that sink in for a second, because, how easy is it to just, as a pilot, to just get locked into your screen and stop looking at what's happening around you pretty easily, right? And it's not hard to imagine if a helicopter, comes over a building and that you can't see it, that's moving in at about 100 miles an hour, or 60 meters per second, roughly. It's not hard to see how that could turn into a collision issue really rapidly. But we can avoid these collisions, or at least we hope to. Next slide, please. So humans are actually pretty bad at this, right? So the other stat that the FAA gave during that presentation that was pretty eye-opening was that for a human pilot on the ground controlling a drone to recognize, locate, and identify and then react to an intruder aircraft is 12.5 seconds. That's pretty slow. So next slide, please. So, and humans have other limitations too, right? Like we get tired, we get sick, and we get bored. If you're a visual observer and you're out in the middle of nowhere and day after day during operations, there's just nothing there. How easy is it to want to go and start looking at Instagram on your phone, right? We're all human, we get it. And when we get bored and get distracted, we start to stare off into the middle distance. We have a limited line of sight. We can only see so much of the sky at a time, so we have to be constantly moving. And we're deployed down in Texas right now with a city down there on top of a water tower. And I can imagine, for those of you that are familiar with Texas, it's hot. especially in the summer. It's very, very hot. And anybody that's been on top of a roof for any period of time can imagine how hot it could possibly get if you had to stand out on top of an all-metal structure like a water tower all day to provide air risk mitigation. That would be terrible. We'd probably, that visual observer would be in real danger of having a serious medical emergency. So a system like Casia G that you could permanently affix to a structure that is always on, scanning the sky at 10 times per second with a 360-degree field of view, and on top of that having the ADS-B antenna providing that cooperative detection. There's real value there and real scalability that's just not really possible with a human visual observer. Next slide, please. So yeah, I think you guys are starting to get this, right? Like this is difficult to do. Humans ourselves are unreliable. There's lots of documented papers, scientific papers about this, about the limitations of human eyesight over long distances. One of the things that humans are particularly bad at is, even though we might be pretty good at recognizing where that there's an aircraft in the area, we're really bad at determining where that aircraft is relative to ourselves, at judging how far away it is and what type of threat it actually poses to an operation. We're really poor at that. So being able to replace that with an automated system that doesn't have those shortcomings could be really useful. Next slide. So here's the key question, right? Can I use this system to get a BVLOS approval? That's what everybody wants to know, and that's probably why a lot of you folks are here today, right? So the answer is, yeah, you could. So we have 2 of them here in the United States so far that we got. Both of them do not involve visual observers. So one with a single Casia G node, one with 2 Casia G nodes. And then our partners in Canada, BVLOS Aerospace, were able to get what's called a Special Flight Operations Certificate from Transport Canada for BVLOS operations at an airport in Ontario. We have a number of customers right now that we're working with on getting additional waivers. This is a pretty new technology. It takes time to get these regulatory approvals. We're really proud of the approvals that we've gotten, particularly because they don't involve visual observers. And we're working really, really closely with the FAA and speaking with them usually a couple times a week on trying to help move the needle for our customers and respond to their requests for additional information, additional testing to get them comfortable with this system. So we already have pretty good precedent here, and it becomes a matter of duplicating that for our customers, which is what we're trying to do. And the FAA, for any criticism you might heard from about them, they are proving to be wonderful partners. We've been getting really good feedback, and there are some wonderful people there that really get it, that understand what the industry is trying to accomplish, and are willing to work with us and our customers to try to get these approvals over the finish line. Next slide, please. More broadly, we've helped a number of different customers, either through our regulatory services or through different versions of our system, get BVLOS approvals globally. So we hold 3 in our name. 2 of those are true BVLOS approvals with no, we hold 4 in our name. 3 of them are true BVLOS approvals, not involving visual observers. And then customers, we've helped a number of different customers get BVLOS approvals. I think we're up over 50 total. One partner of ours, Census Technologies, has helped get their customers utilizing our Casia 1 system over 35 BVLOS approvals, majority of which involve human visual observers. But we've also helped get customers approvals utilizing our system in South Africa, Australia, and we've been participating in flight trials in New Zealand, India, and the United Kingdom as well. We have customers in Europe that are seeking BVLOS approvals using our onboard systems right now, and we have a number of customers here in the United States and Canada seeking approvals for both commercial operations or for public safety operations utilizing our ground-based system in the United States. So this is still the field. The regulatory environment is, of course, ever changing. Different countries are at different places. Different regulators have different levels of comfort with this. But we really do view our system as being a really critically important safety tool just for drone operations in general and aircraft flights, period, but also an important tool to opening up BVLOS operations and really starting to see increased scalability and enabling the remote operations that something like drone in a box really needs to see to start realizing ROI, and enabling autonomous flight operations. So that is it for me right now. I'm actually going to hand things back to Bishali and Achal. So thank you guys. Look forward to your questions at the end. And yeah, guys, take it away.
Thank you, Dan. Thank you for this insightful presentation. The 12.5-second figure as a human response time was definitely an eye opener. There's only so much a human can do, especially if they are, put in adverse weather conditions like rain, heat, storm. And we all know that the operating environments where drone operations are required at scale for pipelines, for power lines, the operating environment is not safe. So I would also now like to call upon Achal to come on stage and share how FlytNow as well is working towards enabling more autonomy and removing humans from loop. So welcome, Achal, and over to you.
Hi everyone. First, let me thank Dan. Dan, that was a great presentation. Really love what you shared. I think it was a lot insightful for everybody in the audience. And this technology is truly actually making BVLOS as a reality, right? Because that is something which is a crucial factor in terms of sense and avoid and getting all that safety. So thank you so much for sharing that. So in my part, I'm going to talk about what FlytNow Auto is doing, the product that we have for drone in the box systems. We're going to talk about a few critical fail safes, the fly zones which we are building and deploying, as well as our integration with Casia G from Iris Automation. So FlytNow Auto is the entire platform which not only acts as a command control center for your operations but powers your entire operations. So you can use a hybrid fleet of drone and docking stations. You can use the right drone of your choice, as well as you can use the right components that would allow you to have BVLOS operations. So over the last 7 years, we've been building the platform in which you can use the right components to automate your drones. Now, this is where this diagram explains where how we are building the hardware layer, the entire platform, and the app store layer, which where we are constantly focused on adding a lot of docking stations, the different kind of drones, automating them through the entire platform, as well as building integrations for your BVLOS operations. So you as an end user or a drone solution provider can go and deploy drone in the box system for security, public safety, oil and gas, surveys, inspection, and much more. As well as you can build workflows for your enterprises where they can integrate their video management systems, ERP systems, or their own private cloud. So we have launched the app store before, and now we're integrating more apps as well as bringing integrations with technologies which helps you do safe BVLOS operations. Moving to the next slide, I want to talk about how the system looks. So far we've been taking a look at the docking station and all the connectivity. And now with the Casia G system, it becomes an essential part for your BVLOS operations. So apart from deploying your docking station, you could have your Casia G unit installed with it. And the things that Dan explained really well, it is swiftly integrated into FlytNow. So you can get all the alerts as well as notifications and have safe BVLOS operation. So we'll see a quick video at the end of the presentation of how this is going to look like as you're deploying these systems with drone in the box with the Casia G. So moving to the next slide, let me talk about the different docking stations which are available right now. So FlytNow today supports 15 plus docking stations, which of course supports DJI as well as your Ardu and PX4 drones. So there are some docking stations which are already being deployed from Hextronics, Haisha, Counter Drone, iDeploy, Escort, and of course DJI is coming with their own dock, which will be soon available for deployments. So FlytNow is already integrated with a variety of docking stations, different kind of drone fleets. So depending upon your application, you can choose the right docking station and drone, and you'll get the unified experience as well as all the integrations that are required for BVLOS operations are pre-built in FlytNow. Moving to the next slide, let's talk about the detailed fail safes where how we are enabling the BVLOS ops. So of course, over the time, we've been building a lot of things which are really critical. So drones, when they came out, of course, they had the basic fail safes, but we had to make sure that those fail-safes are also possible with the docking station. So first we ensure that we can offer all those fail-safes as well as create fail-safes, particularly to the drone in the box systems. So be it low battery, critical battery, these operations are happening over LTE and 5G. So any kind of link loss, what happens? Your RC link loss, that where the drone can lose the connection. You could also lose a connection from your FlytNow side, which is your command center, or there could be timeouts of precision landing as well. So we have given all the measures where it is completely user configurable depending upon the scenario conditions where you're deploying this, where you can set triggers as the percentage as well as timing, plus the actions where drone can safely return to the docking station. So suppose you have 5 drones in the air in the coming time and you lose connections at your command center, you could set the actions to return to safe location or return to a docking station, or let the drone continue the mission if it's in your SOPs, where it could be a safe operation. So we have given users entire configurability in terms of fail safes, where as per your SOPs, as per your risk mitigation procedures, you can set it as per your requirement. Similarly, now one of the major things which where you would be deploying as the conditions, environmental conditions, where the weather could play an important role for your operations. So we have created integrations with weather stations. With all these docking stations now come pre-integrated with weather station. If you have your own weather station, that could be integrated as well. On top of that, we have various triggers and fail safes where you can again set actions. So you can set actions for high wind speed, rainfall, or if your weather station is not connected. So this is again user configurable depending upon where you're deploying. You can configure that as per your standard operating procedures. So this plays a very important role because there could be some drones where you're not rated to fly, or maybe the regulations do not allow you to fly in those kind of conditions. You can set all of that through the weather fail safes events and actions. Next slide, I want to move to the zone space. So we are creating dedicated features respect to creating different kind of zones. So one is of course geofences, where you can set your geofence and restrict the drone in an area and set fail-safe action that should be performed if the drone breaches the geofence. So this is something where you can create a polygon, you can create a cylindrical geofence, and you can set your fail-safe action item. So be it autonomous mission, if the waypoint lies outside, it would the docking station would not open and the drone would not let take off. And in case you took a remote control from the FlytNow dashboard and you're reaching the boundary, the drone will automatically accelerate as well as stop before reaching the boundary. So geofence is one of the very basic necessity for these kind of operations as you're deploying drone in the box systems on your site. Plus some kind of sites where you want to fly over highways or your pipeline. We have a dedicated feature called corridor fly zones. So corridor fly zones would allow you to create corridor missions to prevent drone from entering airspace outside the corridor area. So be it like an emergency response to reach that location, or be it returning back to home. Most of the drones take a straight path back to home location. In the corridor fly zones, they would automatically calculate the path to only use the corridor to reach that location, as well as come back and land using the corridor. So it prevents the drone to enter areas outside the corridor, as well as enforces the drone to remain area for the missions, manual flights, as well as return to home missions. So these are some very critical new features that we have introduced in FlytNow, which allows your operations to be really safe as you are operating them remotely. So next slide. I want to talk about all the apps and integrations which are allowing you to create workflow automation. So in the next slide, I want to talk about, Bashir, can you go to the next slide? Yeah. The UTM for airspace and awareness. So we are constantly integrating UTMs so you can get all the airspace awareness from providers, all the advisories, and you can choose the UTM of your choice. Next slide, please. We are also integrating various parachutes. So you have all the emergency protocol. If you're flying over people, as well as BVLOS operations, parachute are really, really mandatory. So you can integrate with the parachutes with our platform. The next one is about the weather status and updates, where you can integrate different kind of weather services like windy or any other services where you want to get the weather forecast as you're planning, as you're scheduling missions. All of that data is available on the dashboard. Then coming to the main part of the detect and avoid. So all of those things were already pre-built in FlytNow, and the major part that is required is sense and avoid. And that is where we are partnered with Iris Automation to provide a seamless integration into FlytNow. So this is a quick demo showcasing the integration. So you can see a drone on the screen, as well as you can also see the Casia G unit deployed there. And as soon as the Casia G detects an intruder, it is automatically notified on the FlytNow dashboard, as well as an alarm is raised so operator can quickly act now. And this is where we're trying to create autonomous workflows, but based on the surroundings you have, we could have automated maneuvers once that has to be compliant in terms of your SOPs operations, and drone can lower the altitude and come to a safer altitude till the time that situation passes. But the first step is, of course, notifying, where the remote operator is immediately notified of an intruder in that airspace, and that is being done by a Casia G powered by Iris Automation. So we wanted to show you a quick demo so you can get the feel for it, and this is where we'll be happy to closely work with you to integrate Casia G with your docking stations that you already have, or if you're looking to deploy docking stations and getting started with it, you can actually start with the entire combination together. So yeah, that's it mostly from my side. Can we go to the next slide, Vaishali?
Yes. Thank you so much, Achal. Thank you for giving this detailed walkthrough of FlytNow and how is it enabling safety in drone operations, especially BVLOS. So I would now like to open the house for Q&A. Audience, if you have any questions for Dan or Achal, please feel free to ask them in the Q&A tab or on the chat, and I will be happy to take these questions forward to them. So please do so. Meanwhile, I'll just go through a few questions that are already in there, and I'll just check with Dan. So Dan, given that there are quite a few players in the detect and avoid space, what are the benefits or advantages of the Casia G system over the others?
Yeah, I mean, so there are a few different types of technologies that could be utilized for detect avoid. Ours is vision based. There are radar systems. There are acoustic systems. There are a couple systems that are trying to develop lidar based detect and avoid as well. They all have their advantages and disadvantages. No single system is a panacea. And so in many ways, it becomes trying to select the right type of system that's for your different types of operations. So radar is exceptionally good, low at long distance detections. It's going to be really good at helping do detections in poorer weather conditions or low light conditions. A acoustic system is going to be relatively lightweight. It's going to be able to hear for potentially pretty long distances, and a vision-based system like ours, the advantage to it is precision, particularly at low altitude. So we're able to positively identify what we're looking at, and we're not going to struggle with ground clutter. But they each have their disadvantages too, right? Like, so we're not hobbled by, we can pick up parachutists. An acoustic system or a radar system might have difficulty with that, right? Certainly a paraglider that doesn't really, or just a regular glider that doesn't emit noise, that's gonna struggle for an acoustic system. As a vision-based system, we struggle in lower light conditions, and a radar system is going to do better in those conditions. So in many ways, trying to find a system that is going to be right for your operations is the way to be thinking about it. There are a lot of good systems out on the market. I stand by ours. Obviously I sell it, right? But I believe in our system and we do a really good job. But combining multiple systems like an acoustic or our system or radar in our system to fully enable operations, that might be an avenue depending on what you're trying to do. But ultimately, yeah, there are all sorts of different systems out there and they all have their pluses and minuses.
So especially you're on mute.
Sorry. Yes. Thanks, Dan. I think we have a related question. How is it different from counter drone tech?
Oh, good question. So counter drone tech, yeah, this is really interesting. Counter drone tech is really starting to pick up in the space. So counter drone tech particularly focuses mostly, and not every company's this way, but a majority of them try to latch on to different RF signals that are being emitted by drones and try to pinpoint their location and maybe even pinpoint the location of the pilot. So if the pilot's acting illegally, police can find them and take appropriate action where necessary. So that type of technology is really cool. And some of the counter drone technology systems out there are pairing that with high zoom cameras, and so they'll do a pan tilt zoom and lock on to show an image of that drone, which is really great. But there are a couple things about that. So there are other types of detection methods, like or different types of C2 methods, right? Like actually, I just read a paper the other day about a laser-based C2 method that was just developed by a university in, I think it was England, which is okay. Well, that's a new way to control a drone. So like there are different types of detection methods. So a system like ours is a passive based method. We're not looking for RF signals. We're just looking for objects in the sky. So we can detect a whole litany of different types of aircraft. And so that's where the fundamental difference comes in. So a counter drone system is going to be really, really good at detecting drones. We'll detect drones. They got to be a little bit closer, but because they're smaller, they take more, and it takes more a certain amount of pixels to recognize an object. But a combination of those two systems can provide a really and I've been speaking with some counter drone companies as well about putting our systems out together to provide comprehensive airspace air risk mitigation against both drones and general aviation aircraft. Particularly around like events like stadiums and whatnot, because if there is a drone that utilizes a technology that can't be picked up by their system, then we might be able to catch it with just the vision-based system.
Yes, right. I think thanks again for clarifying that. I have a few other questions. So, will the loss of internet connectivity affect the display of intruding aircrafts? I think this is more on to Achal from the software side. If we lose internet connectivity, will that affect the display of intruding aircrafts?
Right. When the first part would be, I think, Dan, you can answer in terms of how Casia is providing that data. And then, of course, I can take from the FlytNow side.
Yeah, so Casia G does require a network connection. So you can, and we can do a whole different bunch of different connection types. So we can use LTE routers. We can use just hardline network connection into, just a local area network. I have a couple customers that have been interested in using Starlink. So there, any way that we could just provide data, we could provide information back. So yeah, that could be an issue. Just quite frankly, if the router goes out or something like that. And so having either having a contingency plan in place in case that happens is going to be really critically important. And that's something a regulator is going to ask you about anyways, which is, okay, well, Casia G system sounds great, looks like it's going to do what it needs to do, but what happens if you do lose that system? What are your contingency plans? And this goes into the broader planning behind a ConOp, and there are ways that you can help mitigate that, either by if the system goes down, maybe the operational area that you would normally have when that's covered by that system, maybe if you have multiple systems together, you don't use that operational area and kind of shift your operational area over. You might have to deploy a VO, but these are contingency plans that will have to be worked out before you get the BVLOS waiver.
Right.
Right.
So in terms of the FlytNow side and the integration piece of it, of course, the default mode is to have internet connectivity. That's how you're achieving remote operations and you're flying it sitting at a distance. But in cases, of course, as Dan said, there are few customers who are looking to deploy it on a private server and everything working on a private LAN. So that is something where we can deploy the system. On the other hand, of course, as you saw, different fail safes. So moving down the line, there could be fail safes, which we'll be planning, where if you have, say, in case of weather stations, we already have it. If you have a link loss on that, you could have a fail-safe action defined that immediately come back to the docking station or reach the safe location or lower the altitude or any workflow that could be created manually to detect that. So those kind of fail-safes would be there with the Casia integration with FlytNow. So we can always have these things, and this would actually help you to write your mitigation plan, risk mitigation plans, that what happens in those kind of scenarios as you're applying for the waiver.
Right. Thanks, Achal. I think we have another question linked to this. This is, after an aircraft has been detected, how the communication takes place to the pilot or the drone and the avoidance maneuver gets triggered. So,
right. So in the phase one, we are not doing any avoidance maneuver, because this is something which we are still right now working where to understand from the operation that what would be the right thing to do. It would be very different for different scenarios. It could have different kind of structures. It could be on a construction site with a crane, and you cannot come to a certain altitude like everywhere on the site. So we are first making sure that there is a big notification on the screen for the remote operators. It could also come on your mobile phone as you're looking at the live operations on the screen on the move, and you are immediately notified when that happens. So that is the phase one. And of course, as you start deploying this and based on a site, the FlytNow allows you to create those kind of different workflows, and that is where we would work closely with you. So it is defined in your risk mitigation, as we've been discussing, depending upon the site you're operating your drones on.
right. Thanks, Achal. I think we have a question for Daniel. Is the vision system impacted by fog and poor visibility?
Yeah, so I get questions about how weather impacts our system a lot. So, just as a general rule of thumb, like, in full disclosure, there's machine vision, computer vision, and human vision don't operate functionally the same way. But when we're talking about, general obstructions in the environment, yeah, it kind of does. So, if you do have fog rolling in, and human visibility, like visibility decreases to the human eye, it's similarly going to decrease for the Casia G system. We still maintain pretty good detection ranges, but we also have to kind of think about, like, what is the system really meant to be tracking, and what are we using it for. And so, as conditions deteriorate towards IFR conditions, the likelihood of non-cooperative traffic being present also declines enormously. And if we get into full-blown IFR conditions, the non-cooperative traffic just can't be flying. They need to be in communication with ATC, and at that point in time, there is no non-cooperative traffic. And the FAA, at least, it might be different in different jurisdictions, but the FAA at least has said repeatedly that it is not up to the drone pilot to be able to pick out and identify folks that are flying illegally. So that is not the responsibility. That's not a responsibility an individual pilot has to burden themselves with. So ultimately, this system is designed for capturing and detecting non-cooperative traffic. So yeah, there is a bit, if you have some light precipitation, some light fog where you're still in VFR conditions, could it impact? Yeah, our maximum range is going to decrease a little bit, not really substantially. But if the situation really deteriorates at a certain point, then ADSB is always going to work, but you're not really going to have to worry about non-cooperative traffic, and so the vision system doesn't really become totally relevant in those situations.
Right. Daniel, I think we have a question around the price of the system. So Denzel's question is, what is the cost of a Casia G solution? If you could maybe throw a ballpark.
Yeah, that's a great question, and it kind of depends, right? Like, so I'm going to give a frustrating answer here because it kind of depends. So the way that we do this is, we have a services model where we help maintain, repair, and help you set up the systems. And we charge based off of the surveillance volume. So depends on how big an area you're trying to cover. So it really depends. If if we're looking at like a single node system, it's low, like about roughly, I'm trying to think because we just changed some numbers here, roughly like 22,000 a year or so, and then multiple nodes, depends on the total scale that you'd want to see. So we can work with you on that, and we have different pricing models that are available for different types of customers. So customers that might be deploying on just a private network, or customers that need to own the system for capitalization purposes and whatnot. So if you're interested in the system, interested in pricing and how we can help, definitely don't hesitate to reach out. Either shoot me an email or reach out to me on LinkedIn, and I can work with you around your particular environment.
Right. Thanks, Daniel. I have a lot of questions for you. Another question is uh, how about trials in the EU, and what is the approach of ESA to facilitate drone operations
Oh, good
in the
question.
specific category of the solution?
This is a
Yes.
good question. I like this a lot because the EU is changing. EASA is starting to get on the move a little bit. So, like, historically, the EASA has been focused on doing things like creating segregated airspace. They've done a big, heavy focus on use space. And there are some countries that are just small enough that just everybody has to be cooperative, right? It's all controlled airspace. So, but what we're seeing is a shift where a lot of funding is starting to dry up for different types of unmanned programs and to help support segregated airspace operations. And so I've been getting lots of questions from folks about our system across Europe, countries as far flowing as Spain, all the way across to the Baltics region as well. So it's just it's starting to shift. And what's happening is EASA is becoming more well. Customers want to start expanding into Class G airspace outside of city environments, outside of dedicated use space areas, and because they can't segregate the airspace, or it's difficult to get airspace segregated for beyond visual line of sight operations. They are looking at non-cooperative traffic detection, and EASA is starting to put a heavier requirement on it. Now, EASA is in some ways a lot more progressive than the FAA, and other ways they're behind, and they're a little bit behind on how they want to evaluate detect and avoid technology relative to the FAA. So what they've kind of stated, like they want evaluations of systems with detect and avoid to help mitigate air risk, but they haven't really defined what they want to see yet. So it's still very much a work in progress, but we are starting to see that shift in the EU towards more of a need for non-cooperative aircraft detection. So what does that mean historically for IRIS? So historically, that meant we've had some projects that have kicked off in the EU back when the UK was still part of the EU, pre-Brexit. So we were doing flight operations in the UK. We have some customers in France that have been doing flight operations, and recently I have a customer in Austria that is working on trying to get a BVLOS approval. But historically, because there has been segregated airspace and more electronic conspicuity, there hasn't been as much of a demand for non-cooperative aircraft detection systems. That is starting to change, though. So I do see I do see a potential for increased demand in Europe over the next couple of years. Do I think it'll match the need in the United States? We'll see. But I think it's starting to grow, and I think we're starting to see a bit of a shift in Europe and how EASA wants to manage, beyond visual line of sight drone operations, particularly outside of use space.
Right. Thank you, Dan, for the detailed explanation. But I think time's almost up. The remaining questions, you'll definitely share them with Dan, or you could just head over to irisonboard.com to reach out to any of the Iris Automation's representative and ask these questions. Dan, if you could maybe drop in your email information or the information on the chat window, that'll help too.
Sure thing.
But again, thank you for joining us today and making time out of your busy schedule to give our audience an insightful presentation. So do you have any last closing thoughts?
Thank you. Thanks again to the FlightBase team. Achal, Basali, thank you so much for having me today. I'm thrilled about the partnership. And thank you to everybody watching from all over the world. I know some of you are in awkward time zones. So really thank you for hanging in there, and really appreciate the time and the questions. And of course, feel free to reach out if you have any additional questions. Either email me directly, look me up on LinkedIn, or feel free to reach out through the IRIS website.
Great. Yeah, thank you so much, Dan. You've got a unique product which is solving the key component for the BVLOS operations, and this is like pan world, so it's not just for one country. This is going to solve problem in different geographical regions, and it is very important for technologies like this to exist for drone in the box, because without that it won't be possible. So we are really thrilled for this partnership that we're doing, and we would like to enable a lot of BVLOS operations with our partners all across the globe. So thank you again for your time and sharing all the insights, all the details of the product, and I'm sure we'll be hosting more success stories together in the coming webinars that we plan to do. So thank you so much.
Thank you. Thank you, the audience as well, for tuning in from wherever you joined. I see people have joined in from different parts of the world. So thank you once again for giving your time. I can also see people requesting for the presentation slides and recording. So definitely we will share the recording very soon, and to all the registrations, and everybody would be able to access them from our website as well. So we'll send out an email with the recording shortly. And thank you, Wesley. Thank you for the encouragement. We also definitely agree that this is the future. Yes, you all have a great day out there. Yes, thank you, Daniel, Achal.
Yeah,
Bye, everyone. Yes.
everyone. Bye.